In the distant future, billions of years from now, our sun will undergo dramatic changes that will profoundly impact the habitability of the solar system. As the sun expands into a red giant, Earth will become uninhabitable and may even cease to exist. At that time, will there still be places in the solar system suitable for life? Could new life forms emerge in those regions? Currently, the sun is in its middle age, maintaining its energy output through hydrogen fusion. This process will continue for several billion more years. Once the core's hydrogen is depleted, the sun will enter its late evolutionary stage and gradually expand into a red giant. In this stage, the sun's radius will increase to hundreds of times its current size, potentially engulfing Earth's orbit. Although the sun's surface temperature will slightly decrease, its luminosity will increase significantly. This will strip away Earth's atmosphere, evaporate its oceans, and turn its surface into a barren desert, ultimately transforming it into a scorching wasteland. However, the habitable zone, where conditions are right for liquid water, will not disappear. It will simply move outward. As the sun expands, the habitable zone will shift to regions as far out as Jupiter's orbit, or even beyond. Areas that were once extremely cold might become new havens for life. Generally, the habitable zone is defined as the region where a planet receives enough stellar energy to maintain liquid water given suitable atmospheric conditions. In the future, some of Jupiter's and Saturn's moons might become more likely to develop life. However, the evolution of life requires ample time. On Earth, life appeared around 1 billion years after its formation. If life evolution needs at least a few 100 million years, will future habitable bodies have enough time? According to recent studies, scientists have analyzed the potential for habitable zones in the solar system as the sun ages. Approximately 7 billion years from now, when the sun is 11.6 billion years old, the habitable zone will extend to Jupiter's orbit. Jupiter will remain in this zone for about 200 million years, after which the habitable zone will move to Saturn's orbit, where it will stay for less than 100 million years. When the sun's helium fusion phase ends, its luminosity will decrease, causing the habitable zone to move inward again. Saturn and its moons will experience a second habitable period, which will last longer, possibly over 100 million years. Nevertheless, whether life can evolve during this time depends on the presence of liquid water on these bodies. Ultimately, as the sun exhausts its helium, it will cease nuclear fusion, and its core will collapse into a carbon-oxygen white dwarf. The habitable zone around a white dwarf is very small and close to the star. However, white dwarfs cool rapidly, causing the habitable zone to shrink quickly. Even if there are planets in this zone, it is unlikely they could develop life. While life on Earth took over 4 billion years to evolve, making the emergence of life, especially intelligent life, a slow and difficult process. After the sun becomes a red giant, the periods of habitability in the solar system will be brief, making it challenging for new life to appear. If life can migrate from one celestial body to another, it's possible that some planets' life forms did not originate there but came from elsewhere. This idea, known as the panspermia hypothesis, suggests that life in the universe might have a common origin, spreading across different planets via asteroids or cosmic dust, including Earth.